Okay, so we're going to continue this lesson on rules of exponents, rules for exponents, however you want to say that. And right now we're just going to do some practice. So notice on this first example, I have z to the negative 12 over z to the 10th. We're going to combine some things because this is a quotient, meaning division, and we also have a negative exponent on here. Now, there are a couple of things you could do. You can just subtract these exponents, right? So we could say, I'm going to show you a couple of ways here. Z to the negative 12 minus 10. Remember, it's a subtraction, so you're taking negative 12 minus 10. And that's z to the negative 22, which is 1 over z, not 10, 1 over z, I was looking at the 10, to the 22nd power. Now, the other thing you could do is right off the bat, let me just do this. You could write this as 1 over z to the 10th times z to the 12th. So a negative exponent, remember, can be rewritten in the denominator. And then add the exponents, because we would use the product rule, right? We're multiplying z to the 10th times z to the 12th. So 1 over z to the 22nd. Now that's the funny thing about the exponent rules. We can use them in different ways as long as it's valid, and it's perfectly fine. So two people working the same question or the same problem might go at it in a different way. And that happens quite often, actually. All right. Next, let's look at this one. So one of the things that we didn't really touch on with the negative exponents is if it's negative and it's on a fraction, we can switch places with it to make it positive. So in this case, we could just rewrite this and have some positive exponents to begin with. So notice I have 18a. I'm going to bring up the a to the negative 3. So it's going to be a positive 3. And then I'm going to take the b to the negative 6 to the denominator. We already had a b to the 6th, but now I'll have another one. And then I can simplify from there. So 3 goes into 18 6 times. Hold on, let me write this. And in my denominator, I'll have the b, but in my numerator, I'll have a to the 4th. And then in the denominator, I'll have b to the 12th. Remember, I took the 3 and divided it into the 18. Let me kind of show that. And that's how we simplified that. So that's one way to go about it. And of course, you could go with the subtracting of the exponents. So if you're using the rules, you should be good with this. Okay, let's look at this next one. We have to simplify the parentheses first. We can't work with this otherwise. So that will be 30z. We're going to add the exponents, so z to the 7th, over 55z to the negative 4. Now I'm going to subtract exponents this time so we can talk about that. 30 and 55 are divisible by 5, so that'll be a 6, and that will be 11. So I'll have 6/11 times z to the 7 minus negative 4. Notice what happens there. So you have to be careful. You can't just think 7 and negative 4 is 3, because that's not what's happening. This is going to be z to the 11th, right? So 6z to the 11th, let's write it this way, 6/11, I don't want to put the time sign, times z to the 11th, or 6z to the 11th over 11. So either way to write that is perfectly fine. I think it's just a preference, what you prefer. put a line there too. On these, we're just more practice again. So notice on the first example, we are multiplying, okay? So we multiply -6 times 2 times -3, which is basically -6 times -6, so we get 36. 8 to the 4th times 8 to the 1st, because notice this, the middle expression did not have an a, so that's a to the 5th. And then on the b's we have a 1, a 3, and a 6, so we're going to add those up, and that's b to the 10th. All right, next we have a quotient, right? We have a quotient. 3 goes into 30 10 times, so we can go ahead and simplify that. That's going to give us 10. And then on the x's, we have x to the -7 minus 1, so that's -8. We have y over y. So what happens with y divided by y? Well, that equals a 1, right? So that's just 1. And then we have z to the -14 minus 1, which is -15. And then we can write this in simplified form because you don't leave negative exponents. Notice it says simplify and write using positive exponents only. So you can't leave the negative exponents in your answer. This would be 10 in the numerator because 10 has a positive 1 exponent over x to the 8th times z to the 15th. And so now we have that one simplified. And last here on these, okay, so we know that 4 to the 0 power is 1, and then this is 4 times 1, so 1 plus 4 is 5, and then we're finished with that. Okay, so those were the rules for this section. We'll have more on the next section. And then we're going to talk about scientific notation. So this is a way for us to write really large or really small numbers and to be able to calculate different things if needed, because it would be easier to put on your calculator. And there's a certain way that we have to write these. So when we're writing in scientific notation, we're going to take the number a, notice this, whatever it happens to be, depending on what we were given in the first place. This has to be a number between 1 and 10. Notice it can be 1, but it has to be less than 10. So, 9 point whatever, 9.9 even. And then we write the exponent on the 10 based on where we moved our decimal. Now, I like to just talk about, this number was large or small. Notice it says move the decimal point in the original number until the new number has a value between 1 and 10, including 1. Count the decimal places you moved in that step. If the original number is 10 or greater, the count's positive. If the original number is less than 1, the count is negative. And then write your product in step 1 by the product of the new number in step 1 by 10 raised to an exponent, right? So we're going to say this times 10 to a power. And it has to do with the counting, which can be a little confusing sometimes. Okay, so let's just practice. That will help to clear that up. Okay, so notice this first number that we're going to write in scientific notation is a big number. It's greater than 10. Originally, my decimal point would be here. And so we want to move the decimal to get a number between 1 and 10. So we would put it between the 3 and the 6. So 3.68, we're going to keep those digits, times 10. And then my power is based on counting from this decimal to where I put it for my scientific notation. So 1, 2, 3, 4, 5, 6, 7. Remember, if it's a number that was greater than 10, it's going to be a positive count. So it's a positive 7. This next number that we're looking at, the 0.00084, is a number that is definitely less than 1. So when we count for our exponent this time, it will be a negative. All right, so first we're going to say, okay, I'm going to take this decimal and put it between the 8 and the 4 so that this number is between 1 and 10. It's times 10, and I move my decimal 1, 2, 3, 4 places, so that would be negative 4. Remember, because this number, I just think big numbers, small numbers, that can sometimes help. This is a very small number. So a negative 4 on that exponent. This one has a decimal at the end, so we're going to put the decimal between the 6 and the 7. 6.78 times 10, and we're moving it 1, 2, 3, 4, 5, so that's going to be positive 5 on my exponent. And then the next one, so I want the number I'm writing in scientific notation to be between 1 and 10, so my decimal will go between the 7 and the 6. 7.613 times 10. I move my decimal 3 places. This is a number less than 1, so it will be negative 3. I still have a little extra something in there on that exponent. And then it's in scientific notation. Okay, and then we're going to go from scientific notation to standard notation. And I personally don't really like to count and talk about left and right. And so you can do that if you want, if it makes sense to you. But for me, I'm just going to say, okay, it's a negative exponent. So that means that I need to make a number very small, right? So we take this 2.7 and we need our decimal to go. It is going to go to the left if you want to think of it that way. We'll have a 0 point, and we need 5 places in between counting the 2. So 0, 0, 0, 2, 7. Now you can always go backward thinking about it that way, right? I had to start with the 2 and count 5 places. So there's 1, 2, 3, 4, 5, and that works. It's a negative exponent, means a number less than 1, and we have that, so that's good. And then the next one, we're going to make this, this is a really big number because it's a positive exponent. When we're counting, we have to count the 3, the 7, and the 8. So 1, 2, 3, 4, 5, 6, 7, 8. Right? And then putting in some commas just helps us with that number. So we move the decimal 8 places. 1, 2, 3, 4, 5, 6, 7, 8. A positive exponent means it has to be greater than 10. This number is definitely way greater than 10. All right, so we have a negative 5, meaning this number has to be less than 1. And we count the 1. So 0.1, 2, 3, 4, 5, right? There's that other place. And then of course we put those 2 on the end. But remember, originally my decimal was here. 1, 2, 3, 4, 5. This is a number less than 1 because it had a negative exponent, so we're good on that. The next one we're going to move, this number is a positive exponent, so we're going to count the 6. 1, 2, 3, 4. We put on the appropriate number of zeros to get that written, and then we're finished. And that's it for this video and for this lesson.